Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
Hey everyone, and welcome to Data Skeptic. Just a few quick announcements before we get started. First off, although many of you have found it, I've never formally announced on the show that you can join the Data Skeptic Slack channel by visiting dataskeptic.com, clicking Contact Us from the homepage, and then entering your email in the box on the next page. In former episodes, I told you to email me for an invite. That's all automated now, so you can sign up yourself. Please come and join the conversation. It's a lot of fun in there. I also wanted to give a quick shout out to everyone who came out to my talks at UCLA yesterday. It was great meeting all of you. I especially liked the Q&A we did afterwards. I'm thinking maybe we should do something like that informally, like a monthly Google Hangout, where listeners can come and anyone can join and everyone's welcome. We just talk about whatever topics people have on their minds. I think that could be a lot of fun. Let me know what you guys think of that, and maybe we'll set something up. Anyone in Dallas, I hope to see you tomorrow, Saturday, February 18th, at the Data Science Conference at UT Dallas. Lastly, in today's episode, I had a chance to speak with Raghu Ramakrishnan, CTO for data at Microsoft. I started getting interested in Microsoft's Azure platform when their bot framework came out. And it's also been really cool to see all the stuff they're doing for data scientists as well. Raghu and I get into a lot of cool topics from SQL to big data and different trends and a little bit of prognosticating. Although rather than describe it, let's just go right into it. So I'm here with Raghu Ramakrishnan. Thanks for joining me, Raghu.
My pleasure, Kyle.
You're the CTO for data at Microsoft and a technical fellow here. So I guess to start off, I wanted to ask, what brought you to Microsoft?
Oh, that's a long story. To give you the short version, I taught for 20 years at the University of Wisconsin-Madison. Database systems, that's my area. Also over the years, did work on data mining, things like this. And at some point, went to Yahoo, where they were starting a new lab and where I wanted to get my hands on larger amounts of data all at once. Spent 6 years there. So some of the things I did there were the first algorithms to create web pages algorithmically. So humans design the page, but the last mile from a candidate pool of articles, what do I actually show you? Algorithms did that. We were also part of the group that developed Hadoop. So we hired Doug Cutting into Yahoo around about the same time I got there. And so my group was both doing some data mining on the underlying data for things like content optimization. But at the same time, in terms of the underlying plumbing, we contributed to things like Pig and Zookeeper and HDFS, Yarn, things like this. Anyway, about 4 years ago, I came to Microsoft. And part of that was the one thing I didn't get to do at Yahoo was build a cloud platform, right? The things we built for ourselves, but here there was an opportunity to be someone who provided this to third parties, to anyone out there. Now, inside Microsoft, on a day-to-day basis, I also run the big data team. We have an internal cloud that's pretty massive. Have you heard anything about it?
A little bit, but tell me more. I'm sure the listeners will be interested.
And also we have a Hadoop service externally. I run both, and in fact, the reason for that is we're trying to bring them together. We have this philosophy that, hey, don't do things in two distinct ways twice. First party equals third party. And inside Microsoft, we have this large constellation of companies. Really, that's what it is, right? Bing and Office and Windows and Halo and Skype. And they all consume data. They store and consume data, analyze data using our internal cloud systems. That's exactly what external customers do. Why not bring these technologies together, build one common stack, leverage all the things we are learning and reacting to internally, also externally? That's the story in a nutshell. But in terms of the internal cloud, it's ginormous. I mean, we have several exabytes of data.
Wow.
The daily IOs in the several hundred petabytes. Right? Everything from search rankings to targeting algorithms to analyzing telemetry from our various products gets done here.
So there was a time when databases ran on single nodes and someone just technical enough could stand one up and work for a company, and if you could afford one salary, they could manage everything.
Yep.
Even still, a company could build their own internal cloud. I saw one of your other talks that the particular word that I thought was very astute was amortizing, that's really what cloud is all about. Could you tell me more about your perspective there?
The usual thing people think of when asking this is, hey, when my machine is idle, if you could use it, maybe we could both amortize the cost and pay less. And that's a big part of it. right? By virtualizing everything from storage to compute and being able to sell in these incremental blocks. What happens is when you have this large fleet of machines that some dedicated group is managing, everyone can then ride on top as long as you have enough fluidity in the system. So you can squeeze all the different people who want to consume in between the cracks. You can indeed amortize all of this and end up with a lower total cost. But I think that's scratching the surface, right? Along two dimensions. The total cost of ownership, frankly, the cost of the machines, the storage, that's not the dominant cost. And it'll continue to go down. It's things like power. It's things like the software on top. It's things like administering them. It's things, all of this for customers who build on top. The true cost is in all the people they bring to bear to understand their domain, to write the data analytics programs, to write the data administration routines. The people cost, right? And this technology is moving so rapidly, retraining people. It's an ongoing challenge. And the number of trained people is so low, hiring people becomes a problem even if you have the willingness and the budget. So I think the other form of amortization is if we can concentrate and build platforms that lift the level of abstraction here. If you didn't have to learn all the nitty-gritty details of every piece of the software stack, and you could instead focus on understanding whatever your domain is, biology or business, and then the tools for making sense of your data in light of that knowledge were that much more accessible. Your data was just there, and you didn't have to worry about it. The total cost of ownership would plunge. And frankly, the use to which data gets put would go through the roof. That's a second form of amortization. If you have a small group building something strictly for themselves, by the time they get up to speed, they don't need all that much hand-holding. And the effort involved in raising the level of abstraction would not be justified or doable for that matter.
Sure.
But when you pool, all this begins to make sense. The last form of amortization I want to bring up here. Historically, people used to say, I don't want to take this data to the cloud because how can I trust someone else with my crown jewels? Well, people are beginning to realize that your crown jewels aren't particularly safe at home. Right? Because securing them is becoming incredibly sophisticated, challenging. Most people simply don't have the qualifications, energy, budget, interest to deal with that. The cloud vendors have to, because if a public cloud gets breached, it's a lot more at stake. Many others are at stake. And to indemnify that, to make sure that you are in a good place, you're going to, by definition, invest a whole lot more energy and people and everything to secure that data. When you go put your data there in such a cloud, part of what you're getting is that amortized halo of the security infrastructure. Net, I think this is pretty much the only practical way we're going to be able to manage the amounts of data we are seeing and will continue to see.
So I like your point about levels of abstraction. When I first dipped my toe into Hadoop, and this isn't a confession because I don't think I'm alone in this, but I found it very difficult. I was a Java developer, but I struggled to make things work. I couldn't understand when they would fail. What are some of the tools and abstractions that are making that process easier today?
At the level of individual tools, there's a myriad of them. But when you think about the ecosystem, you move data using Uzi. You learn about protocols like Thrift. You think about MapReduce and, oh my God, the stragglers. How do I set the parameters right to minimize that? You are tied into a given cluster. How do you remotely connect to it? How do you use REST endpoints like Livy? These are names that most of us didn't know about until a year ago. And a year later, half the names will be gone and there'll be something else to keep track of. The rate of change is making it impractical to learn the tools for most people. It's not just that the tools are particularly more esoteric than tools of a previous generation. It's just that there's so much change and so many things that are frothing. Solution, I think, is not in particular tools, but overall saying, what is it that the tools are trying to enable you to do today? Well, they're enabling you, in a nutshell, to get a cluster, set it up with your Hadoop infrastructure. On top of that, install your favorite app stacks, and then figure out how to get your data in there and then figure out how to keep your data current from wherever it comes from, and then how to run your programs on top. Oh yeah, writing your programs, understanding your world, that's a small detail, okay? And then making sure that no one breaks into this, and then making sure you have all the alerts and monitoring and this and that to let you know when something goes wrong so you can go back and reboot the machines. I think this whole thing is broken. If you look at what I just described to you, not tools, but the things you worry about on a day-to-day basis, 90% of them have to do with setting up a cluster or looking at the details of how to secure your data, looking at the details of just the nuts and bolts of being able to get started doing the thing you care about.
Yeah.
Right? Getting some insight out of that data in the first place. I think we need to flip to a world where these things are made easy, that someone else is dealing with it. Right? Back to the amortization. I mean, at the end of the day, there's some level of effort that doesn't go away. But you can do this as a past service where you say, you know what, you want an HDFS file? Okay, you got it. Just come in and say, create a file. Say, put my data here. And, authentication. Provide the standard authentication mechanisms. Most companies have Active Directory. Others have other systems. But make it possible to plumb directly from there and say, whatever I do here, I just do it with my data in the cloud too. And have it be automatically enforced. And whether your file is 1 gigabyte, 1 megabyte, or 1 petabyte, why should you care? Maybe it's on one machine, maybe it's on 10,000 machines. Maybe 3 of those machines went down last night. Why should you care? These are things that can and should be amortized. What you should ultimately be left with is, what is the structure of the information I'm gathering? Who's able to look at it? When? Why? And, here are the fun tools I need. Let me start playing with my data. And the tools now are not plumbing. They're the tools that let you do your analysis. And in turn, the tool stack should become closer and closer to how you think about your world. Raising the level of abstraction, not just renting you the physical bit buckets. I think that's the philosophical flip we need to make if we are to address this problem of complexity.
We're going to take a quick break to talk about our sponsor this week, Periscope Data. If you heard the last episode they sponsored, you already know how easy it is for data teams to go straight from SQL into interactive charts. I wanted to tell you about their data caching feature. Do you have slow, expensive queries you want to run? What about queries that need to run against a production system, but you're afraid to touch the production database? You can configure data caching to copy that data onto their infrastructure in a way that's optimized for speed. Their caching strategies can make this a reliable source of truth regardless of how your data might be changing. Check out this and many other great features at periscopedata.com/skeptics. Sign up with that link and get a free Periscope Data mug. Once again, that's periscopedata.com/skeptics. One thing I do on the show, as I was sharing with you earlier, is try and do some tutorials, get people to understand things like, what is k-means clustering or decision trees or even the a priori algorithm, stuff like that. I know a lot of your research and your research group when you're in academia focused on how do we do these things at scale. Some problems are embarrassingly parallel, but not all of them.
No.
When they're not, there are trade-offs involved.
Yes.
If we abstract away the challenges, to what degree should someone be informing themselves about what those trade-offs are and how it affects their analyses?
From a scaling point of view or from a results accuracy point of view?
Yeah.
From a scaling point of view, you pretty much summarized it. Some are embarrassingly parallel, and those are relatively easy. But some do require you to iterate over large amounts of data before your models begin to converge. And when that happens, you have a couple of choices. One is, as you're iterating, you can write data back to some safe place in between iterations. This is what the first generation of MapReduce-based machine learning suites did, and they suck, right? The second thing you can do is stick it all in memory. This is what you do when you use Spark, whether you use H2O or something else. Essentially, you're counting on the data being in memory for the duration of all the iterations. This is faster but expensive. The third choice you have is to have a more robust in-memory infrastructure for keeping just what you need across iterations, not everything. And this way you try to sort of marry the two. At the end of the day, across iterations, if you want state in your computation to be carried forward, you do need to pay the piper. But that doesn't mean you need a blunt tool that keeps everything in memory. These come in the plumbing part of the toolkit. They should be there. And the analysis on top, whether it's R or Python or whatever your favorite toolkit, it should be plumbed to run on top of the underlying infra. in a cost-effective way. But when it comes to you, the analyst, deciding when to pay the cost of running on the full data set versus when it suffices to maybe run on an appropriately sampled smaller size, or when you need to sample at all, because sometimes, as you pointed out, what you need to do is embarrassingly paddle. Then you just let it rip.
Sure.
This is where I think you need a good education in statistics. When you think about it all, ultimately, you need to understand when the conclusions you're drawing are grounded. And that's the heart of it, right? Whether you need to sample, if so, how? If not, then yeah, you're paying a bigger, right? All of these decisions, the particular models you're going to build, why you're building them, you need to learn about two things in a fundamental way. You need to understand your domain, right? I don't care how much computer science or statistics you know. If you don't understand your biology, your machine learning in a biological domain is BS.
Sure.
But the other side of it, I don't care how much biology or computer science you know. If you are not a sound statistician, your conclusions are likely to be bogus. And if you're a good biologist and statistician, then my goal is you shouldn't have to be a great computer scientist to get your work done. That, unfortunately, is not the reality today. But that's where I think we as a field need to go.
That makes a lot of sense. So SQL has been the sort of ubiquitous language of data analysis, in my opinion. And I've heard many people say, oh, SQL will die, but yet it survived. Maybe with some abstractions, we've introduced windowing and some other nice tools like that. Do you think it, as a formalism, is the best? Well, I don't know if I'd necessarily say it has to be the best, but will it stick around? Is this going to be our primary language?
You know, once many years ago, I heard Mike Stonebreaker answer a question like this. And he said, SQL is intergalactic data speak.
Yeah.
And that phrase kind of stuck with me. It's true. If you go back, say, 30 years, there were all kinds of files, all kinds of file management systems, IMS, Codicil, this, that. And when all of the data got into relational databases, in large part because back then SQL was a revelation. The relational algebra, SQL, this declarative way of expressing yourself, was light years better than anything else they'd seen. And so as a consequence, all this data came in there. And in turn, that made SQL more popular. It was a virtuous cycle. SQL became ubiquitous because it was your way of talking to the place where all the data was. Now let's fast forward to here. The world is changing. People aren't just looking at highly structured data and looking at reports. They want to look at data as it's generated. They want to look at tweets. They want to look at, the sensors from a bazillion different types of sensor telemetry. They want to look at logs. And they want to read and react as things are happening. They want to analyze text for sentiment. They want to analyze imagery and video for whatever. All this doesn't quite fit in the form factor of tables. Right? Sure, you could just say, here's a blob field and everything's a table. But you know what I'm saying,
Yeah.
right? The things you want to do natively cannot just be expressed as standard select from where statements.
Yeah.
And that's why you're seeing this explosion of interest in tools like, say, HDFS to store this data, and tools like Hive and MapReduce and Spark that let you deal with this data programmatically and at scale. But notice something. The more things change, the more things stay the same. At Yahoo, let me tell you an anecdotal story. We began with MapReduce. In the early days, when MapReduce implementations were, when you take PIG, it was implemented by translating a PIG query into a collection of MapReduce statements. Performance was terrible, right? Relative to you're sitting down and writing the MapReduce program from scratch, performance sucked. Over 90% of all the MapReduce code we executed was produced by translating from PIG within 6 months of even launching PIG as a preview. The story at Facebook with Hive was apparently even more dramatic, to the point where these groups started re-implementing these high-level languages without, sort of taking a MapReduce translation as an intermediate step. That relational declarative way of expressing things is powerful. And you do that a lot of time, even when you start with unstructured data. At some point in your analysis, let me give you an example of something we did. We looked at clicks to figure out which were robot clicks. You had to scrape the logs, you had to clean the logs, you had to run machine learning algorithms to, add features. All of this is not relational. But when you did that, at some point, both for feature prep and for the final analysis, you turned the data into relational forms over which you ran queries, you sliced and you diced up the wazoo. Almost inevitably, whatever you begin with, at some point in the cycle, you're going to want that relational tool. So we are just seeing an evolution of the paradigm for where you keep your data, what the nature of that data is, and correspondingly the tools for analyzing that data are changing to reflect this. You have relational things, Hive, Spark SQL, Pig, USQL, right? But all of them, in addition to the SQL aspects, they also have these open-ended use C# or Scala or whatever to do what you need to. And we'll parallelize it for you. And many more tools, right? Some real-time, some interactive. But what's happened is now with HDFS and Yarn as common sockets, we've opened the door to creating all kinds of analytic tools that plug in and can play nice with each other on top of this walled garden of data. So you'll see a lot more variety, but I don't think you will see SQL go away. It'll evolve to reflect these kinds of extensibility touch points. The SQL Standards Committee will meet again and say, oh God, we have to define 3 new packages now to deal with all these extensions. But in the end, SQL is like Hinduism. It'll continue to be by absorbing whatever comes along.
I think that's a great way to look at it.
Yes.
So with that evolution, I'm going to ask you to prognosticate a little bit. Do you think of all these dialects that are emerging, perhaps they're necessary because they each have nuances to particular edge case problems or whatever the case may be? Will we eventually converge on a winner and we'll just sort of have a broadening of dialects and then a convergence on one winner, or we're going to see like human languages that they just continue to evolve in different directions?
I have no clue. I think in particular verticals, you're going to see higher level interfaces. Whether they are languages in the sense of C or Java, or whether they're just human dialogues of some kind, where it feels like you're talking to a human, but really it's not. Who knows, right? And I suspect maybe it'll also depend upon the domain. If you want to create a healthcare system that advises nurse practitioners, what I'm saying is, if you pick something narrow enough, you can probably build a very intuitive system that covers the common scenarios and then says, wait, this I don't understand, and gives you an escape clause. But when you come to the other end of the spectrum, fully general purpose programming, how much can you special case that? And is there value in particular verticals to have something that's that much closer? Who knows? Already when you think of things like Python and R, one could argue that they are special cased dialects for a fairly broad but yet specialized demographic of users. Quote-unquote data scientists.
Sure.
And back in the day, COBOL was supposed to be that for people writing business reports. And look where COBOL is now, and look where R and Python are. I don't know what the future holds in this regard. I will just say this. Data is going to be there. And tools for dealing with data at all levels will be front and center. Precise details, we'll have fun figuring it out. Especially in this new generation of systems, like I said, with the common sockets. We made it so much easier to just roll your own. Not for an individual, but for a community, and plug it in. So there's going to be a lot of innovation, I think.
So there were a lot of interesting announcements at the keynote at Microsoft Connect yesterday. Is there anything in particular that you're excited about?
Oh, yes. Let me give you a very parochial view. There were a lot of cool things, a lot of awesome Visual Studio announcements. There was SQL announced on Linux. For me personally, this is the time when we announced general availability of Azure Data Lake. So earlier I told you about Microsoft's awesome internal cloud. Azure Data Lake is the next of that. It's combining our internal technology with Hadoop. And this is going to be our future, right? We've already started migrating our internal customers onto it. Today we just announced its availability for the world at large. So we announced Azure Data Lake Store, Azure Data Lake Analytics with a language called USQL. That's really T-SQL, a subset of T-SQL with extensibility in terms of C#, R, and Python. We'll get to Java soon. We also announced general availability of our server on HT Insight. HT Insight is a Hadoop offering. HT Insight, of course, talks seamlessly to Data Lake. we also announced a preview of Kafka for HDI. So there was a whole raft of announcements, including some major ones. Azure Data Lake being GA is a big deal for us, right? I mean, our internal cloud literally deals with exabytes of data and thousands of internal developers. So for us to be able to offer that generally to external customers is a watershed.
Yeah, it's very cool. I really appreciate how you get certain things for free. Like I've been a big fan of R for quite some time, and now if I have data on HD Insight, it's simply available.
And with SQL Server, it's available, right? That's part of the bigger point we discussed earlier, Kyle. This is simplification.
Yeah.
Right? Let's take R. Traditionally, if your data is in SQL Server or Oracle or Hadoop, doesn't matter. The use of a tool like R typically took place in the app tier. You'd call to whatever your store was to pull out the data, and then you'd put it someplace else, and that's when you ran R. Okay. Now, let's think of your typical enterprise scenario where you have taken all kinds of pain to secure your data in the first place, to figure out how to make sure no one can break into it, to make sure you have the right policies as to who can do what with it, to make sure that all your processes are compliant. And then the first thing someone does when they want to run R is they pull it out and put it someplace else.
Yeah.
Oh, God, you begin all over again. Right? And you have to have those auditors sort of crawl all through everything you're doing all over again. This is not good. What the R announcements basically do for you is this. Insofar as you were forced to take it out solely to do your R analytics, you don't need to pull it out anymore. Let's take SQL Server. R runs in proc. So you would use the same ACLing that exists already on your tables. But now any R code you want to write, go ahead, knock yourself out. It runs inside SQL Server, and SQL Server makes sure that the right things happen. Right? You haven't left your compliance boundary. R inside Hadoop, same story. You don't need to take it out someplace to run R. No, you can run R right where the data lives.
Yeah.
Now, this isn't the be-all and the end-all. It's a long way to go. But it's one example of simplification.
So as you were sharing some impressive statistics, things like exabytes of data being processed on the cloud, numbers I couldn't even fathom maybe 10 years ago when I started getting involved in these kinds of things. And there seems to be no shortage of what's being measured and what's becoming observable that wasn't anymore, whether that's retail or IoT or who knows what. Do you think there's a Moore's law of data here at play?
I think there is going to be an explosion of data. Whether it's going to be doubling and doubling every so often at quite the same rate as processors, I don't know. For all I know, it may be faster than that. So there was this projection I saw from a bunch of groups, Gartner, Cisco, that by the year 2020, we'd have 50 billion IoT devices. That's way more than the number of people. That there would be close to 300 exabytes of data being sent over the networks. Numbers like zettabytes were being happily tossed around. Without getting into the specifics, I think here's the reality. A couple of decades ago, when the web companies came to their own, the very fact that they could log every activity on their websites. You search, it's logged. You click on an article, it's logged. You see an article and you don't click on it, it's logged. You sneeze, it's logged, right? The volume of logs, the logs were what made it possible to optimize everything from browsing to search to ad placement. Because you could look at what people did when you showed them something and you could learn from that and show them the right thing. But those logs were order of magnitude larger than anything that any enterprise had collected. And that forced us to build this next generation of technology called big data. If you look at what's happening with IoT and these projections, it's going to dwarf anything we saw with the web. It's another couple of orders of magnitude and just sheer volume. And the scary part, or the exciting part, is this. At the scales we're talking about, there were never more than a half a dozen web companies. There are a lot of companies, but few of them approach the scales we're talking about.
Yeah.
Not true anymore. A tractor, a modern tractor, okay? As it goes down a row, the amount of fertilizer or whatever it gives to a given plant depends upon the surrounding plants, the soil, the temperature, the soil chemistry, the weather in that area for the past week, the signs of the zodiac for all I know, right? It's so fine-grained the dashboard of a modern tractor is more impressive than the cockpit of a fighter jet. Whether you're talking agriculture, healthcare, automotive, as in cars or planes, doesn't matter, medicine, you name it, finance, nothing we do is going to be untouched by this explosively growing ability to observe.
Mm-hmm.
And I think that's what's going to fuel this next cycle of growth.
Makes a lot of sense. Raghu, thank you so much for taking your time to speak with me today. This has been
My
really
pleasure.
enlightening, and I appreciate you sharing your insights.
Thank you, Kyle.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.